Okay, hello students. So I am here with the topic electrolysis from the chapter electrochemistry. Now this electrolysis is the process which occur in the electrolytic cell when your current is passed through the electrolytic solution. Your electrolytic cell, it is your device which convert electrical energy into the chemical energy. Whenever electricity is passed through the electrolyte, the ions which is present there will migrate towards the oppositely charged electrode. Now the electrode which is connected to negative terminal is your cathode, and which is connected to the positive terminal is anode. Now positive to negative electrode, your positive ion will migrate, and to your anode, your negative ion will migrate, and discharge will take place, reduction, oxidation. Now let us discuss what are the product of electrolysis and what are the factors that affect the process of electrolysis. Now, number one factor that affect the product of electrolysis is the nature of the electrolyte, electrode potential of the species. Okay. Now, cathode means your negative electrode, anode is a positive electrode, right? And a cathode ma ke huncha, reduction will take place, and anode ma what will occur? Oxidation will take place. Now, your positive ion will migrate towards the cathode. Now, the positive ion with high electrode potential will get reduced. Suppose there are two positive ion having electrode potential as minus 0.23 volt and 0.0 volt, out of two which is higher, this one. So the positive ion with this electrode potential will preferably reduce at cathode. Similarly at anode, okay, negative ion will migrate and get oxidized. Now the species or the negative ion with the lower electrode potential will get oxidized at anode. Suppose we have two species having electrode potential as minus 1.27 volt and 0.0 volt. Okay, now out of two which is the lower value, this one. No, the negative ion with this electrode potential now will preferably get oxidized at anode. Now next is the over potential. Okay, some reactions are there which are theoretically feasible, but because of this over potential, such reaction will not occur. Okay, now what is this over potential? It is your difference of the theoretical cell potential and the actual cell potential. So the potential which is required for the reaction to occur theoretically will be more than actual will be more than that the theoretical value. So let us take this example. Okay, these are the electrode potential, same example as above. Ion with having electrode potential, this one, so minus 1.27 and 0.0 at anode. Now what we have discussed is at anode, the one with have less value will get oxidized, right? So theoretically, so this reaction, the ion with this electrode potential will get oxidized, but due to if over potential is taking place there, now because now due to this over potential, okay, instead of this reaction to occur, the ion or the species having this electrode potential will get preferably oxidized at the anode. Now next is nature of electrode. Now electrode which we use for the process of electrolysis can be your inert or it can be your active one. Okay, if it is inert, no problem, it won't take part in reaction, but if it is active, then the electrode will take part in reaction. Okay. Now let us discuss the electrolysis of molten NaCl. So here the electrolyte is your NaCl in liquid state, molten, and we know that in liquid state they conduct electricity as because ions are present, right? Now so there is no problem at all because there is only one kind of positive and negative ion. So at anode, which is your positive electrode, which ion will migrate? Your negative ion. So chloride will migrate there and will get oxidized. So how it get oxidized? After losing one electron, and it will convert to atom which is not stable. Okay, so when you balance the equation, you will get this. This is the reaction taking place at anode. And at cathode, which is your negative electrode, okay, sodium ion will migrate there, will get reduced after gaining one electron to your sodium metal. Now what is the overall reaction taking place? Now to your left side, what are there? Sodium and your chloride, right? Sodium and chloride ion. So this is coming from your sodium chloride. And to your right side, what are there? Chlorine, which is a gas, it will liberate, and sodium will deposit at cathode, and anode ma ke huncha, chlorine gas will liberate. So these are the product of electrolysis of molten NaCl. Now let us discuss electrolysis of aqueous NaCl solution. Now what is electrolyte present here? It is your aqueous NaCl, NaCl in water. So NaCl, it conduct electricity again in aqueous medium as because your ions are present, and water also it dissociate as H plus and OH minus. Now at cathode, which is your negative electrode, which ion will migrate? Your Na and H plus. So there is chances of having reduction of sodium to sodium metal, okay, after gaining one electron, and reduction of your hydrogen ion. Now since it is coming from water, so what we can say is water will get reduced to your hydrogen and hydroxide ion. Now balancing it, we will get this one negative charge on both sides, okay, hydrogen 2 and oxygen 1. So this is the reaction. These two reaction might take place at anode. Now let us see cathode. Let us see which one is preferred. Okay, now if we compare the electrode potential of these two reaction, okay, so which is higher? 0.0, right? So the one with the higher electrode potential will get reduced at the cathode. So electrode potential of your this one is greater than electrode potential of your sodium. This is, let this be equation 1, this be equation 2. So equation 2 will be preferred. Similarly at anode, which is your positive electrode, right? Which ion will migrate? Your chloride and hydroxide ion. So chloride ion, when it oxidize, okay, so it will convert to chlorine gas and one electron, isn't it? So and when your water hydroxide will get oxidized, again it is coming from your water, so water will get oxidized to oxygen and hydrogen ion. So balance the equation. कति रहेछ oxygen 1, make this 1 and hydrogen 2. Now 2 positive ion भनेपछि यसले दुईटा electron release गर्छ. So these are the reaction which might take place at cathode or which might take place at anode. Now let us compare its electrode. What we can say, see here, is the electrode potential for this reaction is lesser than this one. So that means it is preferred over the this equation, right? But because of the over potential of your oxygen, so this reaction will occur. Okay, so because of over potential of your oxygen, so instead of this reaction to occur, this reaction or get oxidized, or chloride will get oxidized at anode. Now let us see what are the reaction that is taking place at anode and cathode. Again at cathode, okay, which reaction is taking place? Your hydrogen water molecule is getting reduced to hydrogen and hydroxide ion. And at anode, yeah, given this chloride ion is getting oxidized to chlorine molecule and electron. Now what is overall reaction? Overall reaction, combine the two equation, okay. Now to your left side, what are they? So electron either side, right, it will get cancelled. So left side ma ke cha? Water and Cl minus, it is coming from your sodium chloride, right? So we can write sodium chloride plus water, and what are there on the right side? Hydrogen gas and chlorine gas and OH minus ion, right? What is left now? What is not there? Sodium ion. So these two ion will remain in the solution. So this is the product of your electrolysis of NaCl, aqueous NaCl solution, which is also called brine solution. Your product are hydrogen at cathode, chlorine at anode, and sodium hydroxide at your solution, in your solution. Now let us discuss the product of electrolysis of dilute sulfuric acid using platinum electrode. Now what is your electrode? Is your platinum, and this is your inert, okay, it won't take part in reaction. And your electrolyte is your dilute sulfuric acid. So sulfuric acid, it dissociate as H plus and SO4 2 minus, and your water, dilute means water is present, right, and it will dissociate as H plus and OH minus ion. Now at cathode, which is your negative electrode. Now both is your what? Hydrogen ion, no problem. So hydrogen ion will get reduced. So hydrogen ion after gaining electron will get reduced to hydrogen molecule, which is a gas. Okay. Now at anode, now there are two different ions, right? So two possible reactions are, so एउटा के छ hydroxide ion. So hydroxide ion, since it is coming from water, so anode ma oxidation will take place, right? And whenever oxidation of water take place, हामीले के पाउँछ? Oxygen and hydrogen ion. So now you balance equation. This is your balanced equation which is occurring at anode, oxidation of your water. Now sulfate ion, now it will oxidize to thiosulfate, okay, S2O8 2 minus. Now what is the charge of sulfate here? It is your +6, and here each sulfate 2 छ यता भाइ, each को छ +7. So change कहाँ हुँदैछ? +6 देखि +7 भनेपछि एउटा सल्फेट आयनले कतिवटा रिलिज गर्छ इलेक्ट्रोन? दुईटा. ओके, एउटा भनेपछि देयर आर टु सल्फेट आयन, राइट? दुईटा सल्फर आयन सल्फर छ. सो दुईजनाले कति रिलिज गर्छ? 2 इलेक्ट्रोन. So this are the reaction which might take place at anode. Now the electrode potential of your this reaction is plus 1.23, and for your sulfate is here, this reaction is here 1.96 volt. Now since your solution is dilute, okay, solution ke cha dilute cha is dilute, so equation 1 is preferred as because of its lower electrode potential. So equation 1 is preferred, okay. Now what about when the concentration is high? For high concentration, now equation 2 prefer हुन्छ. Now त्यति बेला के को कुरा हुन्छ? Over potential of oxygen को कुरा हुन्छ. Low concentration मा आउँदैन, when the concentration become high, over potential, okay. So dilute मा equation, this water will get oxidized at anode, and at high concentration sulfate will oxidize to thiosulfate ion. Now last electrolysis that we are going to discuss is the electrolysis of copper sulfate using copper electrode. So here the electrode ke ho timarko is copper, and this is your active one, right? And what is your electrolyte? Electrolyte is your aqueous copper sulfate. So copper sulfate will give copper ion and sulfate ion, and water cha aqueous, right? So it will give H plus ion and OH minus ion. So at now cathode, okay, which is your negative electrode. Now out of 2, now you know that hydrogen ko 0 ho, right? And for copper it is positive, or the copper is less reactive than hydrogen, hai na? So now this out of 2, so isko electrode potential basis hai, so this one will get reduced at cathode. So copper ion after gaining 2 electron will get reduced to copper solid, okay. Now at anode, which is your positive electrode, negative ion will migrate, so there are 2 negative ions, right? Now since your electrode is copper, which is your active, now instead of oxidation of your sulfate ion and your hydroxide ion, okay, if your metal is, electrode is active, now this electrode will take part in the reaction. So your anode ma timro copper cha, so it's made up of copper, right? So copper will now get oxidized instead of your sulfate ion, hydroxide ion, and when it oxidize, ele ke dinja copper ion ra electron release garcha. But suppose timro eta platinum bha, so out of 2, जस्तै यो hydroxide नै तिम्रो के हुन्थ्यो? Oxidize huntyo at anode, but since your electrode is reactive one, so copper will take part in the reaction, or it will undergo oxidation reaction. So this is one of the reaction or setup which is used in the purification of copper, and you might have done this in class 10. Okay, thank you.